Alright, currently you're watching video E4.p2-6, which is notes on fog, dew, and cloud formation. During this time, what we're going to be aiming for our learning targets, what's the difference between the following three things: fog, dew, and clouds, in the way in which they are formed. So that's going to be the main key point. The three terms: fog, dew, and cloud, and how they're actually formed and created. We want you to know exactly what the difference is between each of those formations. There are two terms that you need to know to start off. The first is dew point. This is one that you're going to hear quite a bit. This is probably going to be the first of many hundreds of times over the course of the next couple weeks that you're going to hear this term referenced. And the whole purpose of it is, when you start to talk about the dew point, it has to do with the temperature. When the temperature actually reaches a certain point within our atmosphere, it's going to turn the air from a gas to a liquid. So sometimes it's used the word it condenses, or condensation forms, which is just a shorter term for condensation. So it's a changing of a gas to a liquid form. That's what the dew point is. It's the temperature in which the air will actually turn from a gas to a liquid, so the moisture that's within our atmosphere. The second term is one that you may or may have never even heard of before, and that is condensation nuclei. What a condensation nuclei is, it's a particle. And by particle, it could be a really, really small, tiny piece of dust, or it could be something that comes from, let's say, an exhaust pipe. You get soot, or if you maybe have a windstorm and a small particle of sand gets elevated up into our atmosphere. So it could be a really, really tiny piece of fill in the blank. But what happens is, when that particle is floating in our atmosphere, there's the moisture which then grabs onto it. When the moisture grabs onto it, it's when the condensation, when the temperature changes, and then that's what it holds on to in order for us to actually physically see it. Okay, so in order for condensation to take place, it has to have something to grab onto in order for us to physically see it. So those are the two terms to know right at the beginning. Let's jump right into what is fog. Many of you, especially when we get to the springtime, with the snow melting, unlike this year, but with the snow melting, you tend to find that when we get to the springtime, or when we're transitioning winter to spring, we have a lot of fog. And what it truly is a cloud. It really is. Fog is a cloud, but the difference between fog and a cloud is the fact that fog touches the ground, where a cloud stays suspended up in the air. That's the true difference between them. Fog is a cloud that's touching the ground, where a cloud is elevated and not touching the ground. Okay, so that's the biggest difference right there, is whether or not fog touches the ground or not. All right, so when looking at this picture that you see right here, you can see right here where the fog is in the air, but actually comes down and contacts the actual ground. So again, when you look at what the difference truly is between fog and a cloud, it's where it actually physically touches the ground that is the key and important point to take away from this. Okay, so the formation of fog. In order for fog to actually form so that we can physically see it, you have to take the temperature of the air and then the dew point, the temperature of the air in which the moisture will start to condense and start to show up. It has to be 5 degrees or less. That separates them. So let's say if the air temperature is 50 degrees outside, the dew point 45, and any time that the temperature got within 5 degrees or less, you would then start to see that fog would form. But also keep in mind, it's the temperature of the ground in which we currently, have our houses at. There's grass, fields, trees, and that kind of stuff. But it's the temperature of the ground with the air that is right next to it that needs to be separated by 5 degrees or less. Because again, fog is something that touches the ground, where a cloud is suspended up here in the air. So that's a very key important point, is that it's the temperature of the air which is coming in contact with the ground, and the dew point of the actual air, the temperature at which it will start to condense. The other thing to take out of this is that when water vapor begins to condense, it's when you have these really tiny, small, basically things that you can't see with the naked eye, where you get this water vapor that starts to condense into these droplets. Now, what happens is there's a point in which the air becomes saturated. It has so much moisture at a certain temperature that it eventually lets the moisture out of the air and then eventually falls down towards Earth. And what happens is, or when that happens, excuse me, is when you get something that's called a relativity at 100%. And we'll talk again more specifically about relative humidity and what that truly means. But at this point, what you need to know about relative humidity is it's the amount of moisture within the air that can, until it becomes saturated, until it has so much that it can no longer keep it within the air and it has to release it. And we usually get that as some sort of precipitation. And condensation can also take place. So when you look at fog and you want the real definition of it, the scientific definition that comes from it, what it is it's a very minute, very tiny water droplet that's suspended within our atmosphere, so floating up around us. And what happens is when it reduces the visibility horizontal, so if you're looking in a particular direction, say that you're looking out in this way, they're saying that it's 5/8 of a mile is what they define as fog being formed. So 5/8 of a mile between point A in which you are standing or looking from and then looking at an object down the road at point B, 5/8 of a mile. It is created when temperature and the dew point have become the same or nearly the same. So you have temperatures within 5 degrees of one another, as I said earlier, and then you have sufficient nuclei. This would be the dust, the sand particles, very small things that the moisture can grab onto. That has to be present. If you do not have nuclei, then the fog cannot actually form because the moisture doesn't have anything attached itself to. Okay, so there's fog. Let's talk about dew. Most of you know what dew is. You see it in the grass quite frequently, moisture which forms over the nighttime. And when that happens, it's simply because the temperature, again, when you're really close to the ground surface, the temperature is very close, if not the same, as the ground temperature. So air and ground very close. And then what happens is when the air temperature finally drops to the dew point, the point in which dew condensation forms, that's when you get dew. So what is the definition, the scientific definition behind all this moisture that we find sometimes in our grass when we wake up in the morning? What it is it's condensation in the form of very small, small water droplets that form in the grass and other objects. You could have it on your car, you could have it on your bike if you left it outside, or bushes or any type of plants. And what happens is, and why it happens, is because when the temperature has fallen to the dew point, that's the key point again, the dew point, the temperature in which condensation will form. And it usually happens during the nighttime hours as the sun goes down and the amount of radiation we're receiving from the sun decreases for that particular spot in time. Okay, so again, that's when dew forms. Again, this might be something that you're familiar with having seen, especially during the summer months. You wake up in the morning and there's lots of moisture which has actually formed on the grass. And the reason why, again, that forms is because of the temperature. The temperature up here in this space, the air that's above the grass, is very close to the temperature of the ground. And when they get within 5 degrees or less, the temperature again reaches its dew point, and that's why you get these little particles, small particles of moisture content, better known as dew, that form actually on the grass. All right, so now we've talked about dew formation, we've talked about fog and how it forms. Now let's talk about clouds. Again, remember the difference between what fog is and what a cloud is the fact that a cloud forms up in the air and is not in contact with the actual ground. And then again, dew forms right on the actual ground itself because of the difference in temperature between the surface of Earth and the air which comes in contact with it. So a cloud is something that's just a tad bit different because it is rising air. When you get air which is warming itself up, less dense, it rises up into the atmosphere, it starts to cool. All right, we've talked about this with convection currents as an example. Warm material rises because it's less dense, cold material sinks because it's more dense. The same thing happens. You get rising air, which goes up into our atmosphere and then begins to cool. Now, when it starts to cool, it's again with the things that are floating in the air, as we've talked about, condensation nuclei. You get this moisture, these water vapor that starts to clump together. And by clumping together, they're grabbing onto condensation nuclei so they can start to form, as you and I would call it, a raindrop. And what happens is some of this condensation that takes place is stuff that you can physically see, some of it isn't. For example, you might get something like ice crystals, which you can see in the air. If you've ever looked up in the sky and you've seen a cloud and it appears that there's a rainbow within the cloud, the reason why is because the ice crystals are causing the light that comes from the sun to bend. So you might look up and you see a cloud that appears to be, well, multicolored. I've only seen that a few times in my life, but nonetheless, it does exist. So again, depending on where you live or where you have lived, you might see different things in the sky, depending on the type of weather, depending on the elevation, and multitudes of other things that go into it. But nonetheless, you may or may have never seen these type of clouds in your life. These are called mammatus clouds, and these are called lenticular. We'll talk more specifically about those clouds later on. But nonetheless, how do they form? What makes it so that they form? What you get with cloud formation is it's when you take, again, those very tiny small particles, and those tiny particles will grab onto, as I mentioned before, condensation nuclei. That condensation nuclei allows for the moisture to grab onto it. But what is it that it needs to grab onto? How does it form? Well, the first thing that it needs is written right here. It needs dust, it needs soot, it needs some small little particles that are floating up into our atmosphere. And then what happens is that it will physically clump onto it, grab onto it, and then that moisture will eventually build to the point in which you can physically see a cloud up in our sky. All right, so again, when you look at what scientists would refer to as a cloud, and this is exactly what they would call it. They would call it a very minute particle, very, very tiny particles of matter, such as water droplet or ice crystals that will actually form within the air. The cloud forms in the atmosphere because of condensation, where you actually take the air that's surrounding us, and you cause the temperature to cool to what we've referred to as the dew point, the temperature in which the air will start to condense and moisture will start to form. The condensation nuclei, as you've seen and heard examples of, such as smoke or dust particles, are going to form in which moisture can grab onto to form the clouds in which we physically see in our sky. So how small can this be? When you look at one of these diagrams that I took from one of the National Weather Service sites, you look at the size. So you're looking at 0.0002 millimeters. So exceptionally small little pieces of material that are floating in our atmosphere. And then you look at the average cloud droplet, how big it is, and again, it's exceptionally small, 0.02 millimeters. And then you look at the average rain droplet, the size of it, 2 millimeters. So you look at what it starts off as and how many little clumps have to get together in order to form one, what you and I would call raindrop. It takes a lot. And raindrops, although we think that they're quite large, are quite small on the grand scale. All right, so with taking all of that into account, there are three questions I'd like you to try to answer, okay? The first of which is, what's the difference between fog and dew? So again, taking the term fog and dew, what's the difference between how they form? That's the key word, form. The second question is, what's the difference between fog and clouds and how they form? Again, the process in which they're created and made. And then the third question I have for you to answer is, how is there a difference, or what is the difference between dew formation and cloud formation?